Okay, on the first one, you have a product raised to a power, so each factor in that product is raised to that power. So I have 3 to the second power, x to the fifth power to the second power, y to the third power to the second power. 3 to the second power is 9. When you have a power raised to a power, you multiply your exponents. So 5 times 2 gives me 10, and 3 times 2 gives me 6. So we have 9x to the 10th power, y to the 6th power. On number 2, I'm first going to divide those integers. Negative 27 divided by 9 is 3. And now look at your x and y. There are more x's. The higher exponent is in the numerator for my x's. So I'm going to keep that in the numerator and subtract the exponents. 5 minus 3. Those are the exponents on the x. Now the y, since you have the same exponent, it doesn't matter if you take it to the top or bottom. I'm going to take it to the top, and you subtract your exponents. So I have 3. 5 minus 3 is 2, so that's x squared, and 4 minus 4 is 0. Y to the 0 power is 1, just leaving you with 3x squared. Number 3, you first need to take care of this because you have a product raised to a power. So I'm just going to bring down the 8x to the 4th y and leave that alone for now and apply each of these powers. So that's 2 to the 3rd power, x to the 2nd to the 3rd, and y to the 3rd to the 3rd. Now again, I'm going to bring down the 8x to the 4th y and clean this up. 2 to the 3rd power means 2 times 2 times 2, which is 8. Power to a power, you multiply your exponents. 2 times 3 is 6, and 3 times 3 is 9. Now we're going to multiply the two integers together. 8 times 8 is 64. And when you're multiplying with like bases, you add your exponents. So the x to the 4th and x to the 6th, you're going to add the exponents. 4 plus 6 is 10. And the y's, this is y to the 1st power, and y to the 9th power gives you y to the 10th power. Now we're going to solve these exponential equations, and we're going to do that by getting like bases. 36 can be rewritten as 6 to the second power, and that's raised to the 3x power. When you have a power raised to a power, you multiply your exponents. So I have 6 to the x plus 10 equals 6 to the 6x. Now that your bases are the same, you set the exponents equal to each other. And I have x plus 10 equals 6x. Now I'm going to subtract this x from each side, so I can get the x's on one side. I'm going to bring it up here. That leaves me with 10 equals 5x. Now divide each side by 5, and you get 2. On the next one, I'm going to rewrite both of those with a base of 3. 9 can be rewritten as 3 squared, and that's to the x power. And remember, if you want to bring something from the top to the bottom or the bottom to the top, you change the sign of the exponent. Right now this 3 has a 1, so I'm going to bring it up top and make it a negative 1. Now my denominator would be 1, so I don't have to write the denominator. And that's to the x minus 6th power. The next thing you're going to do is to distribute that negative 1. And I'm going to multiply the 2 and 3 together. So I have 6 to the 2x equals 3 to the negative x plus 6. Plus 6. So when you distribute that negative 1 times negative 6 is positive 6. Now the bases are the same, so I'm going to set the exponents equal to each other. We're going to add x to each side. And I have 3x equals 6. Now divide by 3, and x is equal to 2. Here I already have like bases in number 6, so I just set those exponents equal to each other. Negative 3x plus 1 equals x minus 9. Okay, I'm going to add 3x. Yes, you could have subtracted the x. It doesn't matter. So on this side I'm left with 1. X plus 3x is 4x. Now I'm going to add 9 to each side. I'm going to bring it up here. 1 plus 9 is 10 equals 4x. And now you're going to divide each side by 4. And I have 10 over 4. 10 over 4, each of those can be reduced by 2. So I'm going to divide 10 by 2 is 5, 2 by 2 is 2. This would also be the same as 2.5 if you had it as a decimal. Number 7, I'm going to subtract 2 from each side because I'm trying to isolate that variable term. And I have 4 to the 3 minus x equals 16. 16 can be rewritten with a base of 4, 4 to the second power. Now you can set your exponents equal. 3 minus x equals 2. And I'm going to subtract the 3 from each side. I have negative x equals negative 1, and then you need to divide each side by negative 1, and you get 1. Okay, number 8, you were to omit. Number 9, it says Taylor is training for a marathon. He decides to begin by running 3 miles and increase by 1.5 miles each day. Notice that this says exponential models. So you don't have to decide if it's exponential or linear or quadratic. This is exponential models. Write an equation to represent the scenario. Well, his initial time, A is the initial distance, which is 3, and this is an exponential model. Let me just remind you, A times B to the x power. B would be my multiplier, which is 1.5. So your equation is y equals 3, that's an equal sign right there, it's not letting me do that, times 1.5 to some power x. And then it wants to know how long will it take him to run 26.2 miles. So the number of miles is y. So I want to know what number can I put in for x to get out 26.2. So you're just going to have to do it by trial and error. If I put in a 1 for x, then you're going to get out, let me grab a calculator. If I put in a 1 for x, and I have 3 times 1.5, which gives me 4.5. Okay, I'm trying to get 26.2. All right, let's put in a 2 for x. So 3 times 1.5 raised to the second power gives me 6.75. Okay, that's still not 26.5. And I just put in a 2. I'm going to skip over and put in a 4. So 3 times 1.5 to the fourth power gives me 15.1875. All right, so I still need to go larger. I'm going to put in a 6. 3 times 1.5 raised to the sixth power gives me 34.17. All right, it says, how long will it take him to run 26.2? All right, I skipped. When I put in a 4, I got out all right, let me remind you, when I put in a 4, I got out 15.1875. That wasn't enough. So then I put in a 6, and I got out 34.17185. Let me see what a 5 gives me if I put in a 5. So 3 times 1.5 raised to the fifth power gives me 22 point something. So to be able to run that, it has to be 6. So that is 6 days. So that one we had to do by trial and error. So there's your answer to part B. Here's your answer to part A. All right, number 10 says you bought a Boston Whaler in 2004 for $12,500. The boat's value depreciates. That means it's going down at 7% a year. All right, so this is an exponential model. This is a decay model. Now your decay model is y equals a times 1 minus r to the t power. All right, that's your decay. A being your original price, so A would be 12,500. R being the rate, remember to change it to a decimal, which is 0.07, and T being at some time. So for number 10, part A, your equation would be y equals 12,500 times 1 minus 0.07 to some power. Now you could go ahead and subtract the 1 minus 0.07 and have 0.03 there. I'm sorry, 0.93. 0.93. All right, how much is it worth in 2020? So I have 12,500, and 1 minus 0.07 is 0.93, and I'm going to raise it to, let's see, it was 2004, so from 2004 to 2020, that's going to be 16 years. So I'm raising that to the 16th power. So you'll put that into your calculator, and you're going to get approximately $3,914.10. The difference between number 9 and 10, you were given a percentage. That's why you had to use your growth or decay in this decay model, whereas this one we were given a multiplier. That's why we use the exponential model, which is right there. So when you're given a percentage is when you're going to use growth or decay. The population of a large city increases by a rate of 3%. So that tells me I'm going to use a growth model, which is the same as the decay, except it's 1 plus R. When the 2000 census was taken, the population was 1.2 million. So for A, your growth model is that. And your initial amount is the population of 1.2 million. Now 1.2 million is the same as 1, 2, 3. Okay, that's 1,200,000. And your rate, R, is 3%. Remember to move your decimal 2 places to the left, so that's 0.03. And now I'm going to put that into my model. Y equals 1,200,000 times 1 plus 0.03 to the t power. You could leave that as 1.2 million, but just make sure whenever you state your answer in Part B that you say million if you left the word million in there. Part B, it asks us what should the population be now. Okay, so, and what was the projected population for 2020? Okay, so the population now, it's 2017, so you're going to put a 17 in for T. One plus 0.03 is 1.03 to the 17th power, and that's going to give you about 198,3417. And there's some decimals, but we can't have part of a person, so I'm going to round it to 1,983,417. And then the next, what is projected population for 2020? So I'm going to take the same equation and put in 20. And that's going to give you about 2,167,334. Okay, now I'll turn it to the next page. We're going to identify characteristics of the exponential. All right, the asymptote is right here, and that's at y equals -3. Your domain, since there's no context to this problem, your domain is all real numbers, or negative infinity to positive infinity. That's a comma right there. Your range is going to be the values here and up, so that's all the y's that are greater than -3. Your x-intercept is at 3, 0. Your y-intercept, it looks to be very, very close to 0. Very close to 0. Let's see. So I'm just going to estimate the y-intercept at about -2.9. So that's an estimate. It's going up from left to right, so this is increasing. And your rate of change between 2 and 4, remember this is an interval, and those are your x-coordinates. So x sub 1 is 2. To find y sub 1, I'm going to go to my graph. 2, there's my point, so that's 2, -2. there's your ordered pair, 2, negative 2. And the other x sub 2 is 4. So at 4, it looks like it's at 6. So that's the ordered pair 4, 6. So using these two ordered pairs, I'm going to find the average rate of change, which is your slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, y sub 2 is 6. Y sub 1 is negative 2 over 4 minus 2. So that's 8, because you have to do plus a positive, over 2, which is 4. The next one, your asymptote is right there at y equals 2. Your domain is negative infinity to positive infinity because there's no context to the problem. Your range would be these values and up, so that's all the y's that are greater than 2. Your x-intercept, there isn't an x-intercept. It does not cross the x-axis. Your y-intercept is very, very close to 2, but it's above 2. It doesn't reach 2, so I'm going to just estimate that also at 2.1. This one is going down from left to right. It's decreasing. All right, now for your ordered pairs. Negative 3 is your x-coordinate. Negative 2 is the other. All right, negative 3 is at 6. Negative 2 is at 3. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's negative 3 over, that's plus a positive, which gives you 1. Negative 3 over 1 is 1. Okay, on the next one it says, Mr. Suttle is trying to get more students to come to basketball games, so he starts a competition between freshmen and seniors. The winning class will get free pizza at the game. If the 10 freshmen show up in the beginning and 1.5 times the amount of students show up each hour, and the amount of seniors who show up is illustrated in the chart, answer the following questions. I gave you the freshman equation. All right, that was given. Now the seniors, notice that each time this is being multiplied by 2. So this has a multiplier of 2. Your initial is 5, your initial amount. So that's 5 times 2 to the whatever power, using x. Okay, which class had the most students in the beginning? Well, the freshmen had 10, and the seniors had 5, so the freshmen. Which class had the most amount of students show up between 2 and 4 hours? Okay, Okay, so the freshmen, let me start with the seniors so I can look at the table. This is asking us for the average rate of change between 2 and 4. So for the seniors, at hour 2, they had 20. At hour 4, I'm going to have to expand my table to include 4, and that's going to be 40 times 2, which is 80. So I have 80 minus 20 over 4 minus 2. So that's 60 over 2, which gives us an average of 30. These are my seniors. Now freshmen, I don't have a table for, so I'm going to have to do a little bit more for this. All right, so I need to put in a 2. Again, I could have used the equation for the seniors also. I just thought it was easier to use the table. All right, for the freshmen, I'm going to put in a 2. So I'm going to find y of 2. That means I'm going to input a 2 into that equation. So I have 10 times 1.5 to the 2 minus 1. All right, first subtract 2 minus 1, and that gives you 1. And then 10 times 1.5 would be 15. So this is the order pair 2, 15. Now we're going to find y of 4. So I have 10 times 1.5 to the 4 minus 1. That's 10 times 1.5 to the third power. Okay, you can use your calculator for that, and you're going to get 33.75. So that ordered pair is 4, 33.75. Okay, so now for your rate of change, you have 33.75 minus, this is the y-coordinate minus the y-coordinate, 15, over the x-coordinate, 4, minus the x-coordinate, 2. And this will give you 18.75 over 2, which is 9.375. I know we can't have part of a person, but it doesn't matter because I want to know who showed up, which class had the most, and that would be the seniors.